If a letter is chosen from the word assassination, that letter must be a oval. So therefore, let me take it as an event A. So event A is getting a oval. In the case of 3 heads, you will not contain any tail. So therefore, the probability value will be equal to 1 by 8. If I get the probability of E intersection F is equal to 0, then they are mutually exclusive event. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In our previous session, we have started to calculate the probability of a random experiment. So, in today's session, we will take up few practical problems related to the random experiment and we will calculate the probability based on their condition. Let's look at the first question we have. If E and F are even such that P of E is equal to 1 by 4, P of F is equal to 1 by 2 and P of E and F is equal to 1 by 8, find the first question given is here P of E or F. The second one is P of not E and not F. So, let's solve it one by them. So, first one P of E or F. Or is nothing but union. So, therefore, we take P of E union F. So, there is no condition whether E and F are mutually exclusive or not. So, whenever there is no conditions of mutually exclusive event, we have to take P of E union F in the form of P of E plus P of F minus P of E intersection F. So, here E and F is nothing but P of E intersection F. When you have and, it is nothing but intersection. Now, let us calculate P of E. It is 1 by 4 plus 1 by 2 minus 1 by 8. So, when you take the LCM, you will get it as 8, 2 plus 4 minus 1. The value will be equal to 5 divided by 8. So, this is the value of probability of E or F. Next one, we need to calculate not E and not F. That is probability of not E means E dash and we have and not F. So, and is nothing but intersection F dash. By the property of De Morgan's law, we know that A union B whole dash is equal to A dash intersection B dash. So, here we have E dash intersection F dash. So, therefore, P of E union F whole dash. And also, whenever you want to calculate the probability of a complement, then you have to subtract it by the probability of an event. So, therefore, here I need probability of E union F whole dash. So, therefore, this can be written as P of probability of E union F. So, previously we have got probability of E union F as 5 by 8. So, therefore, it is 1 minus 5 by 8 which is equal to 3 by 8. So, this is the value of the required probability. Next question, A and B are event such that P of A is 0.42, P of B is 0.48 and P of A and B is 0.16. So, determine probability of not A, probability of not B, probability of A or B. So, let's take the first one, probability of not A. So, probability of not A is nothing but probability of A dash which can be written as 1 minus probability of A. What is probability of A? It is 0.42. So, therefore, it is 1 minus 0.42 which value is equal to 0.58. So, this is the probability of not A. Let's take the next one, probability of not B. So, probability of not B means P of B dash. So, that is 1 minus probability of B which is 1 minus 0.48 that is equal to 0.52. Next, we need to calculate probability of A or B. So, therefore, here probability of A or B is nothing but probability of A union B. So, this is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A is given as 0.42, B is 0.48 and this is 0.16 and is nothing but intersection. So 0.42 plus 0.48 minus 0.16. So the value is equal to 0.74. Next question. A letter is chosen at random from the word assassination. Find the probability that the letter is a vowel, a consonant. So we have a word assassination. Out of that, we can separate the vowels and consonant. Let's see how many vowels we have. So we have A, I, O. So these are the vowels. That is how many vowels we have? 1, 2, 3, 4, 5, 6. We have 6 vowels. And consonants. How many consonants we have? 1, 2, 3, 4, 5, 6, 7. So we have 7 consonants. So now, if a letter is chosen from the word assassination, that letter must be a vowel. So therefore, let me take it as an event A. So event A is getting a vowel. So therefore, probability of A can be written as total number of vowels divided by total number of letters. Because favorable to vowels is only 6 letters and total we have 13 letters. So therefore, the probability of a vowel is 6 by 13. Let's take the probability of a consonant. So we have, let me take B as an event where you get a consonant. So from the word assassination, that is 13 letters, we have 7 chances for the consonants. So therefore, the probability of B will be equal to 7 divided by 13. So this is the value of the probability of a vowel and the probability of a consonant. Next question. 3 coins are tossed once. Find the probability of getting 3 heads, 2 heads, at least 2 heads. And for the same question we have at most 2 heads, no head, 3 tails, exactly 2 tails, no tail, at most 2 tails. Let us study all these cases. So first let us write the sample space for this. So when 3 coins are tossed, the sample space is H, 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 T, H, T, H, T, H, 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 T, 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 H, T, 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 H, T, T, T. So total you have 8 outcomes. That is, we can calculate n is equal to 8 outcomes. Now the first one says 3 heads. So let me take A as an event of getting 3 heads. The probability of getting A. So 3 heads have only one outcome. So therefore the probability is 1 by 8. 2 heads. How many 2 heads we have? Let me take this as an B event B. So 2 heads means we have 3 outcomes, HHT, HTH and THH. So therefore here M value is 3. Probability is nothing but M by N. So therefore probability of B can be written as 3 divided by 8. Next one we need at least 2 heads. So there should contain at least 2 heads. Let me take it as an event C. What are the outcomes of at least 2 heads? We have HHH. We have at least 2 heads here. Then the remaining cases HHT, THH. So in all these 4 outcomes, we have at least 2 heads. So therefore, the value of M here is 4. So therefore, probability of C can be taken as 4 by 8 or the value is equal to 1 by 2. Now for the same question, we have at most 2 heads. That means minimum 2 heads it should contain. So what are the possibilities of at most 2 heads, maximum 2 heads? So that is, let me take this as D. I can take HHT, HTH, THH and it can also have TTH, HTT, THT and no tail, no heads. So at most means it is less than or equal to. Maximum it can contain 2 heads, minimum 1 and 0. So therefore we have 7 outcomes here. So therefore, the probability of D can be written as 7 by 8. So when you have the word at least, it means greater than or equal to. When you have the word at most, it means it is less than or equal to. So we have equal to 2 heads and also less than, that is 1 head or no heads. Next we have no head. The only outcome where you don't have no heads, that is all 3 tails. So therefore the probability of E, I can take it as 1 by 8. Next, 3 tails. Again it is same. We have the same event here. So if you take it as FF as an event, so therefore you can take this as probability of F is equal to 1 by 8. Next one we have 3 coins are tossed for the same question. Find the probability of getting exactly 2 tails. So you can get, let me take this as G, exactly 2 tails means you have TTH, THT, next HTT. So therefore you have 3 outcomes. So therefore the probability of G, you can take it as 3 by 8. No tail. No tail means you have only one output, 1 by 8. That is only in the case of 3 heads, you will not contain any tail. So therefore the probability value will be equal to 1 by 8. At most 2 tails means maximum you can have 2 tails, minimum 0 or 1. Therefore, except the case TTT, you can write all the outcomes. So therefore, if you take this as probability and I as an event, the value is 7 by 8. All the outcomes containing 2 tails, 1 tail and no tail can become the outcomes for this event. That is why we have 7 outcome except the case 3 tails, because maximum it can contain only 2 tails. So the next one we have, in class 11 of a school, 40% of the students study mathematics, 30% study biology, 10% of the class both mathematics and biology. If a study is selected at random from the class, find the probability that he will be studying mathematics or biology. So now let us write the probability value. They have given in terms of percentage. Let us convert it into decimals so we can write the probability value. So we have probability of the student studying mathematics is 40%. So I can write this as 0.4. Probability of the student studying biology is 30%. So I can write this as 0.3. Probability of studying both maths and biology is 10%, and is nothing but intersection. So therefore the value is equal to 0.1. We need to calculate the probability where he studies mathematics or biology. That is, we need to calculate the union of this. This is equal to probability of M plus probability of B minus probability of M intersection B. So that is M is 0.4, 0.3 minus 0.1. So therefore the value is equal to 0.6. So if you convert this into percentage, we can write 60% of students study mathematics or biology. Next question we have, the probability that a student will pass in the final examination in both English and Hindi is 0.5, and the probability of passing neither is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing in Hindi examination? So let us write what are all given in the question. So they have given the probability of he will pass in both the examination, that is probability of English and Hindi is 0.5. Next they have given probability of passing neither, that is he will neither pass in English nor pass in Hindi, and the value is given as 0.1. Next, they have given probability of passing in English examination, that is P of E is equal to 0.75. We need to calculate the probability that he will pass in Hindi examination. So, we have to use the same concept of A or B, that is probability of A or B, but here we have two values. We need probability of A or B also. Now here, using this concept, probability of E dash intersection H dash can be written as probability of E union H whole dash. Now this is actually the complement of E union H. So I can write this as 1 minus probability of E union H. So the value of E union H whole dash is given, that is 0.1. So if I need probability of E union H, its value is 1 minus 0.1, its value is equal to 0.9. Now I need to calculate the probability of he will pass in Hindi examination. Probability of E union H is equal to probability of E plus probability of H minus probability of E intersection H. I have the value 0.9, this is 0.75 plus probability of H minus E intersection H is given, that is 0.5. So I need probability of H. So this becomes 0.9 minus 0.75 plus 0.5. So therefore, P of H is equal to, solving this, we will get the value as 0.65. So therefore, what we can conclude, the probability of passing the Hindi examination is 0.65. Next one, events E and F are such that P of not E not F is equal to 0.25. State whether E and F are mutually exclusive. If the concept is here, if E and F are mutually exclusive, their intersection must be equal to empty. So therefore, when you apply the probability for these events, it is equal to probability of an empty set. So what is the probability value of an empty set? It is equal to 0. If I get the probability of E intersection F is equal to 0, then they are mutually exclusive event. Now let us verify here. They have given probability of not E and we have OR here. So it is union not F. That is equal to 0.25. Remember, using De Morgan's law, E dash union F dash can be written as E intersection F whole dash. So probability of E intersection F whole dash is equal to 0.25. And by the probability, we know that the event and complement, when you apply the probability value, the sum must be equal to 1. So therefore, we can write it as a difference from one another. So therefore, probability of its complement can be written as 1 minus probability of E intersection F is equal to 0.25. So let us shift both here. Then it becomes probability of E intersection F is equal to 1 minus 0.25. So we get the value is equal to 0.75. So therefore here probability of E intersection F is not 0. It has to be 0 when you say it is mutually exclusive, but it is not equal to 0 here. Therefore, E and F are not mutually exclusive events. Next one, check whether the following probabilities P of A and P of B are consistently defined. How to check whether the values are consistently defined? The condition is if P of A intersection B is less than the probability value of A and P of A intersection B is less than the probability of value of B, then they are said to be in a consistent. So let's check here. We have P of A, P of B, P of A intersection B. So what we can say here, P of A intersection B is greater than P of A and P of A intersection B is less than P of B. So to say the probabilities are consistently defined, it has to satisfy this condition that probability of A and B must be less than probability of A as well as probability of B. But here it is greater than P of A. So therefore, what we can say, they are not consistently defined. Next one, P of A is equal to 0.5, P of B is 0.4, P of A union B is 0.8. We need to calculate A intersection B to check whether they are consistently defined. So let us verify. We have probability of A union B is equal to P of A plus P of B minus P of A intersection B. So if we want P of A intersection B, we can write it as 0.5 plus 0.4 minus 0.8. 0.9 minus 0.8, we get probability of A intersection B is equal to 0.1. So clearly when you observe, P of A intersection B is less than P of A and P of A intersection B is less than P of B. So it is less than both the probabilities. So therefore, they are consistently defined. Next one, a committee of 2 persons is selected from 2 men and 2 women. What is the probability that the committee will have? So here we come across a selection. So we are selecting 2 persons from 2 men and 2 women. Now the conditions are, what is the probability that we will or the committee will have no men, 1 man, 2 men. So here, let's see the first case. No men means the 2 persons must be selected from women's only. So first let's see what is the total probability. So out of 4 persons, we have to choose 2 persons. And here out of 4 persons, we have 2 men and 2 women. So I can select 2 men, 1 man, 1 woman or 2 women. So the first case is here no men. So here n value is equal to 4C2. Let's find m value for each case. Let us take the first one. So no men means, let A denotes the event no men. Then how can I choose from these 2 men and 2 women? That is, I have to choose women's only. So out of 2 women, I have to choose 2 women's only. So therefore, probability of A here is 2C2 divided by 4C2. So that is 2C2 value is 1 and 4C2 value when you calculate it is 6. So therefore, the probability value is 1 by 6. Next is 1 man. If you select 1 man, the other one must be women. So therefore, we can choose in the form out of 2 men, 1 man, out of 2 women, 1 woman. So this is the selection of 1 man. So therefore, if you take this as probability B as an event, then probability of B will be in the form of 2C1 into 2C1 divided by total number of ways, that is 4C2. Hence, the value is equal to 2 into 2 divided by 6. So, it is 2 divided by 3. The next case is we have 2 men. We have to select 2 men. So, therefore, if you say it has the probability value of C, out of 2 men, I can choose 2 men and out of 4 people, I can choose 2 people. So, this is the same 1 by 6. So when you have a selection, you have to first verify the selection. Then with the total number of selection, you will calculate the probability value. Next one, there are 4 men and 6 women on the city council. If one council member is selected from committee at random, how likely is it that is a woman? So we have 4 men and 6 women. We have to select only one person from the committee. Total we have 10. So total we have 10. So what is the value of n then? Out of 10, we have to choose only one person. and we have to calculate the probability how likely it is a woman. So what are the chances of selecting a woman? So therefore women, out of 6 we can choose 1 woman. So therefore if you take it as an event E, that is of choosing women, then the probability value is 6C1 by 10C1. That is 6 by 10 value is equal to 3 by 5. Next one. In a lottery, a person choose 6 different natural number at random from 1 to 20. So we have 20 numbers. Out of that, we have to choose 6 numbers. And these 6 numbers match with the 6 numbers already fixed by the lottery committee. He wins the prize. What is the probability of winning the prize in the game? So if he has to win the prize, the 6 number he has chosen must match with the 6 number which they have already fixed. So let's calculate the probability. So now here, what is the total probability n value? Out of 20, he has to choose only 6 numbers. Now, if I denote A, that he wins the prize. If he wins the prize, what is my favorable outcome? That is, out of 6 numbers they have already fixed, he has to select all those 6 numbers. So let's calculate the probability value. That is, probability of A will be equal to 6C6 divided by 20C6. So 6C6 is nothing but 1. 20C6 is nothing but 20 into 19 into 18 into 17 into 16 into 15 divided by 6, 5, 4, 3, 2, 1. So we can calculate here. We can cancel 5 4s are 20, 6 3s are 18, 2 1s are 2 8s are. So we have the value of 1 divided by 19 into 17 into 8 into 15. So let us see the value here. So that is the probability of the event value is 1 divided by 38760. So this is the value of the probability that he will win the prize. So this is all about the chapter probability, that in this session we have taken some practical problem to evaluate the probability value. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.